This is a video for section 9.4. We're going to cover at least one of the questions in this video and one other question in another video. Now, in terms of the problems in section 9.4, all of the questions revolve around the same basic concept. That concept is the formula that we learned in class the other day, A equals P times 1 plus R over N to the power of NT. Now, for us to utilize this formula, we have to know all the details for this formula. Secondly, we have to be able to read the question that we're provided and identify what information they're asking for us to find and what information we're given. Now, if you can't read this clearly, that's okay. I'm going to go through it. I'm going to pull out the information that's important. I'm going to write that in a little bit bigger. I apologize for the video quality. The camera that I'm currently using is not the best. So, the question is, how much must be deposited today into the following account in order to have $45,000 in 5 years for a down payment on a house? Assume no additional deposits are made in an account with annual compounding at an APR of 8%. So we're going to start by writing down that 45,000 is important. Well, that is the A value. Now, in most of the problems that we've looked at, okay, in terms of in class or otherwise, the A value was what we were looking for. But in this case, the P value is what they want to know, because the question asks how much must be deposited. And remember, P is the principal amount. That's the amount we're putting in. This is the amount we want to get back out. So A is 45,000. Our value of T, which in your MyMathLab will set the formula as Y, not T. But either way, they're the same thing. And again, that's the only thing that would be changing, is that would be changing to a Y. Well, T, in this case, is 5 years. We also are looking at this information that says an account with annual compounding and an APR of 8%. So I'm going to write down APR first. In terms of APR, APR is 8%, but we cannot plug 8% into this formula as it is. We first must change that to 0.08, a numerical value that doesn't have the unit of percentage on it. The last detail that we need to identify is the N value. Again, we know what A is, we're looking for P, we have R, we have T, and we just need the value of N. With this piece of information, we're going to again identify that this is the number of times it's compounded in 1 year. Since this is annual compounding, it's only going to be compounded once per year. Again, if we said had a monthly situation, if we were looking at monthly would be N is equal to 12. If we were looking at, say, weekly, there are 52 weeks in the year, so N would be 52. We also have maybe daily and a few other possibilities, but N for daily is 365. Do not be afraid to use these values where necessary in this formula. Again, for this one, N is 1, because we're compounding once per year. So let's plug all this information into the formula here. I'm going to have 45,000 equals to P, which is the unknown value, times 1 plus my rate, which is 0.08, divided by N, which is 1 in this case, and N, which is 1 to the power, times 5, which is the number of years. So now this is the formula we're attempting to solve. Now with this piece of information, what's nice about this formula is even though it looks a little bit daunting, I just have to evaluate what this number is here in the exponent. I have to evaluate what this number here is as the base, and I just have to get P all by itself. So 45,000 is going to be left unchanged. P is going to be currently left unchanged. I'm going to be combining these two values, and if you want, you can plug those into a calculator, or just notice that 0.08 divided by 1 is 0.08. When I take that and add it to 1, I just get 1.08. And now let's recall from class that this value right here was the rate, that was the factor that we're multiplying by. That's the factor at which this amount that we invest is going to change by every single compounding. In this case, it's going to be to the power of 5, because 1 times 5, if I simplify that, is 5. Notice how I did this. I did the base inside the parentheses. I did the exponent separately. After I've done that, I'm going to go ahead and get my calculator out. And in my calculator, I'm going to type in 1.08 to the power of 5. Now, you may not be able to see it on my calculator, but when I hit enter, it's going to give me a number. That number is going to be 1.4693280,768. Again, I would recommend that you try doing this on your own and get the same exact value. Now, the difficult part comes from, at this point, solving for P. So this is 1.4 ... so on and so forth, all multiplied by P equals to this number. How do I get p by itself if I'm taking p multiplying it by this number? Well, to remove that value, I'm going to go ahead and divide by it. Now, some of you might be thinking, why did I write all of these decimal values down? It seems like it's a lot of extra work that we shouldn't have to do. Well, when working with these problems, you shouldn't really be rounding until the last step. Now, again, keep in mind that's a 1 point. Let me make sure that those are very clear that those are decimal values. So, if I divide this side by that value, those two values will cancel out. I'll be left with p is equal to whatever 45,000 is divided by that number. In my calculator, if you've got a nice scientific one, you can go ahead and do this accurately by selecting the previous solution. Okay, so I'm going to do 45,000. Sorry, that was 45. Let me fix that. 45,000 divided by 1 point whatever, and I will end up with p being $30,626.24. Now again, that would be the amount that I have to invest into this account so that at the end of 5 years I'm going to end up with 45,000. Again, this is the formula you're using in this situation and in every situation that revolves around compounding at a specific rate. Okay? Do not be afraid to use that formula. Do not be afraid to write all the information in and attempt to solve for the missing value. That will be the end of this first problem. Again, there will be one more video for a second problem.